Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze a compression bone plate for its modal analysis. We will start by double clicking on modal module. We'll first go to engineering data sources. Now in general materials, you will find only stainless steel. So this is not the material to be used. In ANSYS Granta materials data, here you will find stainless steel 316. This is the material required. So I'll select this material. I'll go to project and update project. Next we'll go to geometry and right click. Import geometry. I already have the geometry made with me, so I'll directly import the part. I'll give you the link for this geometry. You can download and use it for your analysis. So I'll select it. Next I'll go to model and double click. I'll go to geometry and select the part. I'll go to material and assign 316 stainless steel. Next I'll go to mesh and I'll change the element size to 1 mm. And you can make it further smaller. It depends on the configuration that you're using. I'm using 1 mm here to reduce the time of computation of meshing. So this has been created. Next I'll go to modal and I'll right click and insert fix support. I'll fix up all these holes inside. And then I'll click on apply. Next I'll go to solution and solve it once. You can see here 6 modes have been created. So I'll right click here, select all. Again right click, create mode shape results. 6 mode shapes will be created. I'll go to solution and solve. Now let's see the various frequencies obtained for this compression bone plate and what is its equivalent deformation. The first one is 24120 Hertz and the equivalent deformation is 1096.7 mm. This is the maximum value. You can just animate and see the result. Now the frequency which is obtained here is quite higher and this is generally not attained by the compression plate. So the bone to which the compression plate is attached will be safer as this high natural frequency will never be attained. Next is for the second mode. The value of frequency is 24151 Hertz and the total deformation is 1098.9 mm. That's the maximum value. You can again animate and check the result. For the third deformation, the value of frequency is 38092 Hertz and the maximum value of deformation obtained is 984.8 mm. So again the value is quite large, so it is unattained actually. The bone and the plate both will be safe. Now for the fourth deformation, the value of frequency is 38,134 Hertz and the total deformation, that's the highest value, is 985.96 mm. For the fifth mode, the frequency value is 39,083 Hertz and the maximum total deformation is 1272.6 mm. For the sixth mode, The frequency is 39,150 Hertz and the maximum deformation is 1271.7 mm. As you can clearly see that these values are quite high and this will never be attained by the plate. So your geometry is very much safe using this material, and plate can be very easily used, and it is actually widely used in the market for the fracture purposes of the tibia and the femur bones. So nowadays you will see that this 316 stainless steel material is being replaced by other materials as well in the market. So if you are doing an analysis, this is the way to do the modal analysis to know if your plate is safe given the boundary conditions and the frequencies of various objects around us which can create a resonance in the body with this metal plate. So you can analyze and you can compare the result. I leave that to you for analysis and observation. With this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.